Hello and welcome to ActiveView. I am Jaqui Wassenaar, Vice President and Market Development Director for RGAX EMEA based in Amsterdam, and co-presenting with me today will be Jeff Heaton, Vice President of Data Science for RGA based in St. Louis, Missouri. Today we'll be tackling the subject, the evolution of the actuary in a world of automated machine learning. Before we talk about actuaries and machine learning, let me introduce RGA and RGAX. RGA is a Fortune 500 company and leading global health and life reinsurer. In 2015, RGAX was established as the transformation engine of RGA and as an extension of RGA's decades-long commitment to innovation. RGAX builds on a legacy of continuous innovation by partnering with clients and entrepreneurs to address existing industry challenges, explore new opportunities, and build and expand the future of life and health insurance. We focus on 4 lines of business, namely insurance services, consumer engagement, digital distribution, and lastly, data and analytics, which is an area of increased collaboration across RGA and RGAX. We continually look at new technologies and new partners in this space, seeking unique data sources for life and health insurance applications, and our large team of data scientists are continually developing and testing their data modeling techniques. Given that data and analytics is integral to what we do across RGA and RGAX, Jeff and I are honored to share our thoughts on this ever-changing topic today. The insurance industry has been using data to price risk for years. But now, with the increasing types of data we have available, including semi-structured and unstructured data, it's a very exciting time for insurers as well as consumers, as it really opens up the doors for new products and new product development. An example of this is the plethora of data that we see coming from wearable devices, which are increasingly being incorporated as part of life and health product designs. Then there's also credit data. Access to vast amounts of structured and unstructured credit data have allowed us to build models to understand the highly predictive nature of credit on mortality. This enables insurers to potentially tailor the underwriting requirements for prospective policyholders who better manage their credit risk. And thirdly, quite an exciting field is the unstructured data that comes in the form of digital images. A number of insurers are embarking on insurance offerings based on facial analytics technology. And while it's early days, we believe we're on the brink of seeing highly accurate gender, age, and BMI assessments possible via a simple selfie, from which an online quote, application, and purchase process can take place. These are really exciting times. Data is truly transforming the art of the possible when it comes to insurance, but it's not just the availability of data that's exploding. There's also been an exponential increase in data storage capacity. According to an International Data Corporation study, by 2025, the worldwide data that we will have seen would have been 175 zettabytes. A zettabyte is 1 trillion gigabytes, so we're talking about 175 trillion gigabytes of data available. And it's also estimated by the IDC that the storage industry will ship 42 zettabytes of capacity over the 7-year period to the end of 2025 in an attempt to meet the burgeoning demand. At this intersection of the ever-increasing data sphere, massive increases in data storage, coupled with computer processing power, we see an acceleration in the development of machine learning and AI to the extent that we're asking the question, are we at the precipice of an AI revolution? Revolutionary change is hard to grapple with, especially when it comes to our professions. And if one types will automation in a Google search bar, the first 4 AI-generated autocomplete sentences are all job-related, starting with, will automation kill jobs? And as knowledge workers, actuaries are likely to see a huge transformation in our roles. We really are quite at risk. If we don't act to ensure that our profession evolves in the face of increasing automation, we may find ourselves possibly as obsolete as blacksmiths at the end of the Industrial Revolution, which is quite a scary thought. At a 2017 InsurTech conference, Daniel Schreiber quite famously said, "The next insurance leaders will use bots, not brokers." and AI, not actuaries. How replaceable are we? This is a big question that we have to ask ourselves. But before we ask that question, I'd like to hand over to my colleague Jeff Heaton, who is VP Data Science for RGA. Jeff has a PhD in computer science from Nova Southeastern University, and he's held several roles with RGA over the 20 years that he's been with RGA, including IT, underwriting, and most recently in data science. Jeff's team allows RGA to bring data science models into production implementations for RGA and many of RGA's clients. Jeff, as I hand over to you, will you tell us about automation and the type of automation that you're seeing transform our industry and our roles?
Thank you, Jackie, for introducing me and for this great overview of this exciting new technology. So I'm Jeff Heaton. Let me go ahead and take you through an overview of what do we mean by automation, like Jackie asked. What do we mean by AutoML? So AutoML and automation in general are ways that we can take tasks that were traditionally performed by human beings and allow machines to perform these tasks and work on them in an augmented fashion with human beings. Data science in many industries is used to help automate things like fraud detection, valuation, lapse detection, things that were traditionally done by actuaries. Well, data scientists can help automate their own job as well. So we're completely willing as data scientists to apply this same technology to replacing ourselves as we are everybody else. Now, the reality is there's no replacement really going on here. We're giving greater tools to augment people's jobs to be able to perform things faster and over much, much larger amounts of data. Because like Jackie mentioned, the data is only getting bigger. Automation also is not binary. It takes a lot of science and a lot of time to truly close that gap where you're able to have complete automation. Look at the self-driving cars. They've made some really advancements in the last years. I mean, really, self-driving cars started, in my opinion, with things like anti-lock brakes and other things that you just don't want to have to think about as much as a human being, and you're ready to let a machine automate. But that last 10 to 15% where you need to really have complete automation, where you could have a self-driving car that doesn't even have a steering wheel that you would be confident letting a child ride in. That is the complete automation, and it will be some time before we reach that. We're definitely striving towards it, but closing that last 15% is much more difficult usually than closing that first 85%. Now the data, as Jackie was saying, we've got all this really cool unstructured data that we would like to be able to process, and AutoML definitely can help us out in that area. But let's talk about the types of data that we really have that we need to deal with in the life insurance industry. So at the far end of the spectrum, we've got structured. Now, structured data is data that looks really nice in Microsoft Excel. You've got columns, you've got rows, and the columns have nice names on them. Everything is well-defined and is very structured. Also, like relational databases, usually if you're dealing with SQL and you select all this data back, the select statement really is turning it into structured, because the results from the select statement are a nice grid that would go right into Excel. Semi-structured is more like that relational database behind it. You might have one person with 5 addresses, and that data just doesn't fit as well into Excel because you've got my name, but then how do you represent those 5 addresses? You'd have to basically have 5 groups of columns, and maybe they'd be filled in, maybe they wouldn't, and it just doesn't fit as nicely. That is your semi-structured. Very common formats that you see for structured is CSV, but for this you'll see JSON and XML because they let you deal with this hierarchical data where you can group things into hierarchies and have connections between elements. Relational databases in their pure form are semi-structured because they have all these tables that are related to each other. And then at the other end of the spectrum, you've got your unstructured data. And unstructured data, that's the real area that we're trying to deal with and try to really unlock its potential, because most of the interesting data out in the world is unstructured. This is raw text, like doctor's notes in a coding system, or images, or scans. OCR is a way to structurize that, but maybe dealing with the images and the text in their pure form, or looking at images of EKGs and other labs and diagnostics that were performed on patients. And then PDFs. PDFs mostly have text in them, but there's other data in there as well. Very, very unstructured. Now, you have to deal with all these different types of data. Now, the next thing that the data scientist has to do, and this is where AutoML can really be helpful, is dealing with what type of model do you want to use. Now, I'm going to break the models into three large categories. You've got your supervised models. That is where you've basically got those rows and you've got the column that you're trying to predict, so you know the answer. You want to train the model to give you that answer that you're expecting so that you can use this on rows in the future where you don't have that target column filled in. Examples here are neural networks, GLMs, support vector machines, gradient boosted machines. And an example here would be lapse modeling or predicting underwriting risk. Lots of insurance applications for supervised learning. Unsupervised learning is where typically you're trying to cluster things. You don't have that Y column that you can use. Now, I have had people come to me sometimes and say, we don't have any labels, we don't have any Ys, but we want to predict this column. We want to predict this column that we don't have any data on. That's not unsupervised learning. That's wishful thinking generally. But that would be a form of supervised, and you would have to somehow approximate that value. But unsupervised is where you've got lots of customers or policies or something, and you want to group them into common cohorts or personas. And knowing this allows you to market or service this particular customer better. A good example of this is something called recommender algorithms. These are used by Amazon and online retailers. As soon as you log into Amazon, they're going to greet you with all the things that they think you would like to buy. And those were predicted probably by some sort of recommender algorithm or similar. Another type of unsupervised learning. Self-supervised, this is the new one. This is really exciting. And this is challenging to apply to life insurance. There are cases. This is where you've seen things like Go and like chess, where the neural network was able to completely dominate the field of chess or Go. I mean, a human cannot really defeat a chess computer anymore, nor can it defeat a Go computer anymore. It's complete dominance. And the reason these were able to be trained so effectively is because the algorithms, the neural networks, the machine learning algorithm can generate its own data and have as much as it wants. Think about a game of chess. You can verify who won the game of chess completely with a computer program. You can't verify an underwriting decision completely inside of a computer. You'd need to run some simulation that could run the entire human body and simulate it. That's simply not possible at current technology. But reinforcement learning is very good when you need to learn a series of steps, like in complex underwriting applications that you might go through, and figure out what is the ultimate policy or the ultimate set of steps that you would have used to underwrite or to achieve, in the case of chess, checkmate, or in the case of underwriting, a person who has limited risk and you're able to collect premiums for a long, long, long time before they meet their ultimate demise. This is a typical AutoML system. This is also fairly typical of the flow that a human data science team might go through. that box that I have, the AutoML, you'll notice some pieces are partially in, partially out. The middle part is really what you would probably use for an AutoML system. So you've got raw data that comes in. You're going to do the data cleaning and wrangling. The data is going to have numerous issues. You're going to need to be able to really remove columns, rows that are problematic, and scrub it and get it into a form where it can be fed into a system like this. This is both where AutoML really shines and sometimes doesn't shine, because it's not aware of what the data actually is. It can look at all of the data, it can do the normal distributions on it and say, okay, these things that are out in the tails, they're probably wrong, but maybe they're not. It might take Jeff Bezos and on an income plot and say, wow, he's way out in the tail. He cannot possibly be real. And they would eliminate him. Human beings would know, okay, there are really people that rich, and you would know how to process that. Once the data is in, you need to select columns that are actually important and extract features from columns that are somewhat unstructured, like textual. AutoML can do a lot of things here where it runs through a lot of well-known features that you're able to create, and it typically does quite well. It'll lack the human intellect where you're sometimes maybe a medical doctor would know to rank certain conditions by overall risk. Unless there's a lot of data that the machine learning algorithm can learn the risk on its own, it might be more difficult for this to be automated in a way that these features can be created. Column extraction, again, just getting data out of these columns and re-representing them in a way that makes them more predictive. Once you've got your features extracted, then you're ready to do model selection and hyperparameter optimization. So hyperparameter optimization, most models like neural networks support vector machines. They've got all these knobs and dials on them. It's kind of like dealing with a DSL camera in full auto mode where you've got to set aperture and shutter speed and ISO and all these other things that I have just a vague idea of what they do. And it's not like you can set just one of these dials and get the best result and then optimize the other. They're working together. If you change one, the other has to change. AutoML is great at doing this. It can optimize and rerun these models and find that best set of hyperparameters using mathematical operations so that it doesn't have to just trial and error, do everything under the sun. And it can use massive compute power by using the cloud to spin up a bunch of computers and be able to segment this task among them. Now, as you're selecting models, you're trying neural networks, you're trying support vector machines, you're trying GLMs. Once you've got your top models, you can then pick between those. And some of the AutoML packages, they'll give you literally a listing of them. They use almost the same term that Kaggle does. They have a leaderboard. And you pick what models you want to potentially ensemble with others. Ensembling is teamwork for models. Maybe neural networks can deal with one type of data or one segment of your rows better than a support vector machine. By ensembling these together, you figure out a way to average the score coming from each of these or segment the data as it goes into the ensemble. And then you're able to come up with a new model, this ensemble, that deals with coming up with the best score no matter what your data is coming in as. Now, some models like random forest, they're already an ensemble, but that's a homogeneous ensemble. It's a bunch of trees ensembled into a forest. What I'm talking about here is heterogeneous models, where you've got a heterogeneous ensemble of these models where you have a random forest ensembled with a neural network ensembled with a support vector machine. Once you've got that ensemble, then you're ready to validate it. The AutoML does a great job of validating these models, doing holdout sets and a variety of things, and showing you really how well the model fits to the assumptions that the AutoML program has made. And that weakness is the same weakness that a data scientist has as well. Often, as a data scientist, you're validating how well the model worked to your original assumptions. If those original assumptions are wrong, then hopefully you will be able to validate that in some way so that you know that an issue has occurred, but you might not. That's why it's good to have other subject matter expertise in the organization. Data scientists, I'm not an actuary, so I will often rely on actuaries within the team just to get a different perspective so that I'm able to validate and really have confidence in this model. Now, there's some human-led enhancements that really led to the AutoML capabilities. One of those is deep learning. So normally what you try to do is take your unstructured data and structurize it, make it fit into the more traditional models. Deep learning promises end-to-end, where you can take the unstructured data in and get structured or unstructured data out depending on what you had trained it for. There's neural networks that will accept an image and return an image, or accept data and generate an image from it. So there's a lot of capabilities and powers there that deep learning can promise to do some of the feature engineering that you would have normally relied on a human being to do. Bayesian optimization, that's a way to deal with that hyperparameter optimization where you are adjusting those knobs and dials and not just trying everything under the sun, but really coming up with a good way to set those hyperparameters so that the neural network or support vector machine, that you're going to really get the best version of that model that you could. Like I said, it's kind of like the settings on a camera and fully manual mode. You've got to set all of those up and to find just that one that when you snap it, you're going to get the best picture. That's the exact same thing. You're trying to get the best model. And then Lime, that gives explainability so that it's able to explain the model and really let you be able to give reason codes and other things to explain to subject matter experts who are trying to validate your model that it's really doing what you would expect and that its decisions are sound. Now let's talk about some of the appropriate domains for AutoML in the insurance industry. If you've got a large amount of data, this is an area that AutoML will really shine at, because you've got all those combinations for every different type of health ailment. It's going to be able to know if that's a healthy person or not. If you've got a smaller amount of data, you might be using something like BMI as a predictor. And if you have just fairly normal data, you're going to see that high BMI is unhealthy, low BMI is healthy. But if you don't have enough examples of really low BMI, the model is going to naively assume that somebody with a BMI of 1, which I don't think is even survivable, would be a very, very healthy person, because it has no examples to show it that that extrapolation doesn't continue on into infinity. Relational databases, this can be very good, where you've got all these complex tables going everywhere with different types of joins. The AutoML can get a hold of those tables, bring the data all together, and be able to build a model on that, even though the data is very semi-structured. And the AutoML, especially if you can give it schema information and explain the cardinality of how these tables come together, it can do quite good at extracting features from it. Now, these are going to be fairly naive features based completely on the data, so you always need to look at it to make sure that these really make sense and that it's using data that's appropriate to be using. Or models that must be recreated and regenerated in real time, like marketing, where you're moving ads around on a page to try to optimize it. There's no regulator that's going to come to you and say, okay, why did you move that ad over there? You need to explain it. These are very quick models that may be thrown away in a month. An AutoML package can be great to get those very rapidly into production. And you just validate it by throwing 1,000 users at it and see if they clicked on the ad any more frequently than the others. or companies with limited access to data scientists. If you just simply have not built up a data science team, or it's not practical for you to do that, AutoML can be good in certain domains where you can very quickly prototype something and build a model. You just need to be careful if these are models in high stakes area, like issuing a life insurance policy, where the cost of being wrong is very, very high. Domains where human judgment is definitely needed. If you don't have much data or the data are very sparse, you really need humans to connect those dots. Humans who understand the data. Underwriters, medical doctors, actuaries, all understand their respective types of data and can help really deal with building a model on this very, very small data. Everybody talks about big data, but small data is often more challenging to deal with because you need to build a model with just limited amounts of data. The AutoML deep learning, they are brute force algorithms that just use massive compute power to deal with tons and tons of data. If you do not have that data available, it's a much more challenging prospect where you probably need the help of a human expert. Okay, we've talked about AutoML, and I've showed you some of the technology that allowed to bring it about. There's obviously lots of ramifications for AutoML across many, many industries. I'm a computer scientist. I've got some ideas for what it means in the life insurance industry. But Jackie, I'll turn this over to you. What does AutoML and these things that we've talked about in our presentations, what does this mean for actuaries?
Thanks, Jeff. The world of data science is a fascinating one, and so thanks for taking us through the latest developments. To answer your question, it really does have a big impact on actuaries, and it's quite an exciting time for actuaries, in fact, with the proliferation of wearable data, digital images, even PDFs. As you know, actuaries love data, so the fact that AutoML opens up these new data sources for us is really exciting. Additionally, it frees us up from some of the more routine and previously time-consuming parts of our role to focus a lot more on the client-facing elements and also some of the more creative parts of actuarial roles, which a lot of people don't understand. A lot of actuaries have quite creative elements of our roles, which I think most of us do love. So those parts of the actuarial role will be quite hard to replace. I mean, as we know, creativity is not something that's easily replaced by AutoML. And I also believe that actuaries will still play a significant role in the traditional sense, in the fact that we'll still play quite a guiding role. If one considers, for example, as you mentioned, gaps in the data or very sparse data sets, we know that the data that we use is not always complete. Contributing to this is regulation. So while there's a proliferation of data, we might be quite constrained in the ability to use all of that data due to, for example, data privacy laws. Also, if one considers consumer behavior and adoption, that consumers are able to opt out of providing their data. So depending on the level of consumer adoption, it can definitely impact the completeness of our data sets. And then fourthly, often there are controversial data sources. So actuaries will play a significant role and continue to play a significant role in determining which data sources should be used as variables. As Jeff alluded to earlier, AutoML is utterly naive. So the actuary will play a role in making sure that that naivety is ironed out, so to speak. So we don't know what the future holds, but what we do know is that there's definitely an evolution taking place. We definitely know that the actuarial profession is evolving and will continue to evolve, most likely to coexist alongside AutoML. We know that for future actuaries, the actuarial syllabus is evolving and will evolve to incorporate more and more data science training and techniques. And in fact, the future actuary might look quite different from what it looks like, from what he or she looks like today. The future actuary is most likely a combination of the current actuary and the current data scientist. It's also encouraging to know that the actuaries in relationship roles and senior management roles will continue to be really important within our industry, and so there will likely be far more emphasis on these roles going forward. It's also always important to bear in mind the legal and regulatory environment. These considerations will mean that actuaries will always be necessary to make those decisions in morally questionable situations in deciding whether to use, for example, a contentious variable. I really do love the quote by William Pollard that says, "The arrogance of success is to think that what you did yesterday is sufficient for what you do tomorrow." It's really relevant in the context of actuarial science in the face of machine learning. But I do believe that we will retain a really important role in our industry, and for those of us that are willing to learn, to adapt and to evolve, there are exciting times for us to make sure that we coexist as an industry alongside machines and remain relevant. All of this is really important, not only for the evolution of our profession, but most importantly for the end consumer. Thank you very much. I hope you enjoyed the session today with Jeff and I, and whatever you're doing, wherever you are in the world, have a wonderful day further. Thank you and goodbye.